Good day everybody and welcome back to my channel. I've finally got good news, finally. And I don't know if any of you have actually been trying to trace this out in your own time, watching my videos and have actually traced it out. You might already be laughing at me. If you haven't, you're gonna laugh at me. I'm laughing at myself. I've been doing electronics literally since I was a little kid. I'm a 32-year-old man now, so I should have noticed this. I will admit that. You know what they say when you make an assumption? You make an ass out of you and me. Well, that's true. When you assume, you make an ass out of you and me. Well, I did that because I assumed. Let me just get a pen and paper so this really makes sense for everyone, because I want everyone to understand where I went wrong here. I guess it's more important that I understand where I went wrong, but just so everyone knows. Yes, this is the most happiest you're going to hear me on this, because I expected to work on this for a couple of days, basically put better op amps in them, compensate them, stiffen up power rails, add some high frequency suppression to areas that I know could use it, as someone who works on builds power supplies and amplifiers and stuff like that. You know, lower inductance. I wanted to make it a little bit better, but mainly just restore it to its original form. Like, I haven't changed any of the way the circuit functions, you know, like I might have put better op amps in there, but they're still doing the exact same thing. I haven't changed resistor values. I haven't changed the way the circuit works. I've just used better parts, basically speaking. Where I did go wrong changing the circuit, and this is absolutely hilarious. I thought, so the transformer, the mains transformer, and we're just going to look at one channel, right? Actually, I don't even know that that's true, but I think it is like this. I think the main transformer windings got for each channel like a positive 55 volts and a negative 55 volts. That zero might not be there. I'm not sure. I can't remember. And then there's the same, you know, there's the exact same thing for the other channel. And then there's a whole bunch of small center tapped windings, like I don't know, 6 of them, 8 of them, like a lot. They're 30 volt windings, end to end, 30 volts, 15 volts to the center. So I thought, and all the driver circuitry, the op amps, they obviously ran off the smaller isolated taps that aren't the main output tap. No. Oh shit. Fuck. You scared them. You can't do that. Whew. I've got so much stuff just precariously set up and balanced in here. It absolutely scares the crap out of me when a cat comes running across the desk. I'm just like, oh, no, please don't. No, not up there even. No. What are you doing? Hey, you're not out in here. Get out. Out. No, I just lost the top of my pen. Ah, God. And the lead. My pen, my pazer. Right. Dumbass Dave here assumed. I'll make this nice and big so I can really make it make sense. Fucking hell. Get out! I'm busy! No. Man. My missus will be back next week. I can't wait, because I cannot deal with trying to start a YouTube channel up, trying to start a business up. I'm slowly stocking up on equipment and components and stuff that I'm lacking, and then looking into insurance and reactivating my ABN and all that, and getting a repair business going, because what I want to do is design equipment and sell it, and obviously that's going to take time. Basically high-end audio equipment and stuff that goes in labs, like precision power supplies, load banks. Start with small stuff like that and move my way up. you know, and other miscellaneous products for like niche markets, like people who build amplifiers that wants to say, oh my God. Sorry about that, guys. The lock on the inside of my lab door doesn't work, so this is bullshit. I'm gonna have to fix this. That'll do. Whatever works. Right. So yeah. Then I've got like random little things that are not complicated at all, but very handy for niche markets, like people who work on audio amplifiers. I've got a huge load bank that I'm designing that's got 300 or 500 watt resistors, like 4 ohm resistors and 8 ohm resistors, and they're going to be banked up with basically jumper jacks going like a box with a whole load of these on them, and then basically a whole load of jumper links so that you can link the different resistors together. You know, basically make 4 ohms, 8 ohms, 6 ohms, whatever you want, you know, by putting them in different arrangements and different numbers of channels and different wattages. So huge ass load bank. This is the intermediate stage, and off of that load bank it's going to have BNCs and all sorts of stuff. I'm going to even take the time to run signals through it and make sure they come out exactly the same, and if I have to build a little compensation network, like a little adjustable RC snubber sort of thing, I'll do that if I have to, because this is all going to be for audio analyzation, so it has to be perfectly accurate. Anyway, this one, same thing, BNCs, so you can have a look on your scope at the output or your audio analyzer or whatever you're using. And then here's your inputs, and there's nothing is tied to ground. I've just got ground. It's a double-sided circuit board in there, so the whole back plane's ground, and then in between the positives and negatives and the two channels there's grounding too, so it's basically shielding. And the box, that all goes to that. Anyways, so what this is you can put your left channel in here, right channel in here, not from the output. Say you're working on a preamp or an intermediate stage or something like that, and you want to load it down. I've got so you can put these switches on in the on position and have all these other switches in the off position, and then you've got pots, only half a watt dissipation, but you can go in between 10k and 1 meg. You can also add that in with the fixed values. Now the 470 ohms, I've written all on the bottom here. 470 ohms are 10 watts, the 1k is a 5 watts, pots and high value resistors are half a watt. So that's, and if you do the math, like, you know, 10k at half a watt, for an intermediate stage, that's fine, you know. Anyway, it's a load bank for intermediate stages, front ends, VASs, preamps, all that sort of stuff. When you want to load it down and look at it on a scope, that's what I built that for. But anyway, that's what I want to do. I want to make a whole niche of different products ranging from big and small, start a company, and I figured the best way to do that is to start a repair business in the meantime, make money out of that and use that to save up to invest in my product design, basically. Anyway, I'm getting carried away. That's not what this video is about. So, actually, these are plus minus 15. Sorry. Right? What I imagined was happening in this power supply was that the op amps, so that's your positive, that's your negative, that's your output, and your two inputs. I imagined one input was looking at the voltage on the output referenced to 0 volts, and the other input would be looking at a VREF. Sorry about my writing. I should be using a finer tip for this. Reference to gain to 0 volts, right? That's normally how you would do this. Positive would go to positive, negative would go to negative, right? And then your output would go off to one end of the OR gate. Obviously, this is the one that controls voltage. There's going to be another one that controls current, you know, and its output's going to go off to the other end of that OR gate that is on the 2 op amps. Anyway, that's how we do things nowadays, and well, for quite some time. I mean, I've worked on old Agilent and Hewlett-Packard designs, and yeah, I've worked on some old power supplies, and they've all still been set up like this. Now, I don't know if anyone's going to get what I'm talking about when I say this, but back in the old days, things were constructed using more PNP transistors, and they were sort of built upside down, so to speak. If you've worked on enough old stuff, you know what I'm talking about. That's what's going on here. I don't know why I just assumed that it wasn't like that, because if I had have actually realized that in the first place, basically all the filtering caps that I put on there, I would not have put where I put them, and we'll get to that in a second. So what's actually happening here? We've still got our winding center tapped, minus 15, plus 15, 0. But guess where our op amp's getting its power from? This is what's really annoying. The Zenas I think I just drew them the wrong way. I'm not really fussed about that. The point is, it's literally designed like this, and just for ease of simplicity, let's just use the output reference pins off of this side. Everything is referenced to the rails. It's literally the complete opposite of, you'll get what I'm saying, right? It's literally the complete opposite. Sorry, I didn't draw Zenas in here, because that's how they are deriving the 210 volt rails, 1N4740s everywhere. Right, so it's literally back to front. Why is this a problem? Okay, so I've been sticking capacitors in between the rails, thinking, again, lowest potential down here, highest potential up here, and I'm thinking that I am essentially shunting noise across the rails by putting a capacitor or capacitors across the rails. But I'm not. Because it's referenced to the 0 volt point, all I've done I screwed that up royally. I can fix it. All I've done is put capacitors like this. Yes, these are 2 rails created off of 1 rail, but because it's at the center of the transformer and the 2 windings at either side of this, I'm not shunting noise from the rails. I'm basically passing noise that's on this rail to this rail and on this rail to this rail, and probably creating a bit of a tank circuit with the Zenas and the capacitors too, or maybe the op amps even. So that I've basically made the power rails resonate more than what they were. So that's my fault. So with this newfound knowledge, I guess now what I'm going to go do, lucky for me, most of everything I've done on here, or basically everything else, is perfect. It stays. All I have to change is the capacitors that I've put across the op amps and the Zener rails. I've got to remove them. I'll probably put the 10 nanofarad capacitors back on the Zener rails for now, because I think what they did is they just used as small capacitance value as they could to shunt out the Zener noise between the two Zeners, and there's nothing else added there because, well, like I said, it's all between the center 0 volt rail and the actual rails. Oh, sorry, wrong board. That's what all this is for. The filtering's done across the rails, not from the rail to the center point, if that makes sense. So, well, I guess the capacitors still go in between the rails and the center point, but the way they're taking power off of the capacitors is basically in reverse to how we would do it. So I'm going to take all those capacitors off, just those ones that I've added across, like I said, the op amps. So that, and that. Oh, and these ones. And I'm going to stick back the 10 nanofarad capacitors that were there. The other thing I'm going to do before I do that is I'm going to show you the other discovery that I made, because this changes everything, literally. Yesterday I spent some time looking over this, and I actually came to the conclusion that these two op amps were not driving the panel meters. And then after I spent some time tracing everything out, we'll get to why that happened in a second. After I spent some time tracing everything out, I realized they actually are driving the panel meters. So that makes a lot more sense now as to why the panel meter kicks back, because yesterday I went through this whole absolute trip, I don't know what you want to call it, where I was sitting here scratching my head, because I'd looked at some of the circuitry and it appeared like the panel meters would just run off resistive dividers, like a resistive divider off the current shunt and a resistive divider off the output, you know, going back to the volts amp switch and then directly to the panel meters. So I thought they were just doing it like that, like the real old school way. And that's when I started tripping balls, because I was thinking, how on earth can the panel meter go up and then kick back if it's literally just wide across the output? That doesn't make any sense. So it wasn't then that I realized it was actually driven from the op amp. It was actually when I made the discovery I'm about to show you guys now that I found out when I started tracing out this reference circuit. I just happened to notice a trace I didn't spot before that actually goes, I think via a resistor. I think there's this top resistor is the gain setting resistor that goes between the negative input and the output of this op amp. And I think there's a resistor that runs off of this that goes to the panel meter or something like that. And I didn't spot that before. I just spotted connections from the panel meter going to these resistors and these two pots and the inputs on this op amp, but I didn't see anything from the output. I didn't notice anything from the output, so I just came to the conclusion that the op amp wasn't actually driving them. Anyway, this is where things get really interesting. So I can't remember if I've already shown this in another video or not, but whether I have or not, it doesn't matter, because now I have an answer as to exactly what's happening here. I want to go over this. I need to move my phone over a bit. One sec. Right. Perfect. Oh, my meter's charged up. By the way, low battery indicator comes on, stays on for about half an hour, 20 minutes, and then the thing gets below the threshold voltage for the boost converter in here, and it turns off, and the battery's still got like 2.7-ish volts in it or something, which is just under its threshold. But the thing is, I only put the red light there so that when it comes on I could finish my work and plug it in. So I won't do that ever again. I only did that one time just to see how it works, and it works beautifully. blue light comes on when you're charging it. When it's done charging, the blue light goes off. When the battery starts to get low, the red light comes on and gives you time to finish your work and turn it off and go put it on charge, basically. So yeah, if you turn it on when it was, if you how to explain this, hard kill the power switch whilst it's already on, it'll boot back up in on position. If you turn it off and then turn that off, when you turn it back on, it'll be off. That's all you're seeing there. So I'm just gonna have to take a phone call. One moment. Right, sorry about that. I'm back. I'm just gonna move this back so that you can, because it's two supplies, we're only looking at one channel at a time, so you only need to see half the board. That way then you can see what I'm doing at the front at the same time as the board and the meters. This will make sense in a second. So, we already know about all the oscillation problems on all the op amps that are, well, at least looking at the constant current and constant voltage. Probably the ones that are involved with reference stuff too, and well, definitely the panel meter ones, because the panel meters do run off of the op amps, and as you know, they go up and then kick back all of a sudden. That's an op amp going out of range all of a sudden due to something, and I don't think it's its input limits going out of range. Obviously, I think it's oscillation causing a sudden offset, and you know, it's causing one of the transistors in it to all of a sudden switch states, basically. Anyways, I'm going to turn this on, and we're going to have a look at the reference voltage and see that it's 3.6 volts. I'm going to put a short in here, a bit of solder wick, and we notice the reference voltage has gone down. Now watch this. I'm going to turn the current up towards an amp, and look what happens when it's in an amp. The reference falls down to 2.7 volts. I know what you're probably all thinking, because the first thing I was thinking was maybe one of these resistors that someone had changed with those smaller ones that were burning was the wrong value, and the two top references just weren't getting enough current in the first place, and then after the supply's loaded and the rails sag a bit more, there's literally not enough current at all. That was my first theory, until I did this. Yeah, I can short across the reference, and actually I'll do this a different way. I'll get my analog meter, I'll stick this in amps mode as it is across the reference. The reason I'm doing this is because with no reference, the current's going to obviously... I gotta just turn these around. Right, so as you can see, we've got about 6 milliamps. Not much, considering the bottom references are running 37 and the top one's only running 6 milliamps. But I'm going to take the shorting bar out just so that you can see the actual current, right? Because with no reference, I can turn the current all the way up to like 4 amps or something, probably at least double to 4 times what it was with no reference. Because the op amp compares the monitored current against the reference voltage. So the higher the reference voltage is, basically the smaller your current limit would be. The lower the reference voltage, the higher the current limit. That's shorted. So there is no reference right now. So I'm going to start winding the current up. And what do we notice on the analog meter? I'm at 2 amps. This thing's only supposed to go up to an amp. We'll go back to an amp. There's still 6 milliamps there. It drops by about 1.5 milliamp. About 1 milliamp actually. It goes from 6 to 5 milliamps. So, the voltage is dropping, but the current is not. And I think everyone knows that a TL431 can certainly regulate at 5 milliamps. Let me just have a quick look at the data sheet, what it says. Let's see. Sync current capability 1 milliamp to 100 milliamps. Well, that wouldn't be written there if the thing couldn't function at 1 milliamp, obviously. I'm pretty sure they can function smaller than that, but maybe not for the TL431A, but maybe the B version that I've got. Because I know that goes down to 35 microamps. I'm pretty sure. Or milliamp, no, microamps. Hold on a sec. Where is it? ATL431. I don't have the data sheet loaded up. One moment, please. Data sheets. ATL. There it is. Right. The ATL431BQDZR. Yes. IKA minimum 35 microamps, IREF 150 nanoamps. So if it was a current problem, I could always just replace these two with ATL 431s, BQs. But it's not. There's enough current there still for a TL431 to work. A variety in the TO92 package, just a normal one. So I propose what's happening is that as the oscillation increases, it gets to a point that the TL431 is internally oscillating so much that it just, probably the band gap reference in there or the comparator, one of the two, gets screwed up and goes into oscillation and changes its output voltage. Because obviously if the current's not dropping across it, oh, and let's just look at one other thing too, because I haven't checked this myself. So instead of just looking at the voltage across the TL431, let's look at, well, its supply, which is between here and this. This is its dropper resistor. 10 volts, right? Let's load this down. You see the 10 volts is still there, right? Oh wow, I just blew the fuse. You know what happened? That wasn't putting out 1 amp. I can see smoke coming off that resistor. Fuck. That's not good. I hope I didn't just pop the transformer. I just saw the power light go out and heard a click, so I'm pretty sure the fuse just popped. It's a little 1 amp fuse. Ah, shit. Oh no, yeah, it's the fuse. I thought my transformer's main winding just went open for a second. So what happened there is the thing went into oscillation and it was putting out about 12 amps. You know, like when I've got my meter hooked up to the output and I see it all of a sudden peg up, I take it off straight away. Well, that time, let's just say I didn't notice. This will do for now. I do have the correct fuse in here. I just can't be buggered finding it right now. I just put a 3 amp fast blow fuse in, just temporarily. It's not loaded right. Don't want to make that mistake again. Anyway, as you can see, I loaded the crap out of it. Literally 10 times the current was supposed to come out of it, or 12 times, 11 times to be precise. It puts out 12 amps when it goes into oscillation. I'm going to have to measure that resistor and them two and make sure I didn't raise the resistance of them or open them. Anyways, the voltage supplying the reference does not drop. The current does not drop, hence it is oscillation. You know what that means? Everything in here is working. There's nothing to fix. I just got to do, sort out the power rails, compensate the op amps. Where I went wrong was putting capacitors across what I thought was rails, but kind of isn't, effectively just shunting noise from one side to the other, passing it into more places than it already was. If I had realised that, obviously I wouldn't have done that. But so what I'm going to do now, let me just put these back. If I leave stuff out everywhere, I end up with a really messy lab, and let's just say it gets to the point that it ends up overwhelming. So what I'm going to do is I'm going to take the boards out. Hopefully this is like the second last time I have to split them. I'm hoping to take these capacitors out, put the 10 nanofarads back in there. Now I've stiffened up the rails so much I probably won't need to filter the op amps. They are filtered. I didn't realise that these were the caps that are filtering everything. I don't know why I didn't think of that in the first place. Like, what else are they doing? Anyways, yeah, that was silly of me. I really should have just had a good look at it first before doing that, but oh well. Lesson learnt. Don't assume. Well, at least not on old stuff that's probably built different to how we build stuff these days. So what I'm going to do is I'm going to remove the capacitors that I was pointing out just before. I remember they only had two 10 nanofarads. That's like one 10 nanofarad capacitor for these two op amps, one for these two. Well, I guess I can just count how many are in here, because I've kept all the parts I pulled out in the bowl. Because like I said, what I do is, with the old parts, I keep them for something old that I need original parts for. I'll go through and individually test all the parts, and you know, all the good op amps and good resistors and good this and that I'll keep. And when I'm restoring an old radio or trying to build a replica old radio and I want it to look all original, I've got some old components. So this will go to my old school component collection. I have to do a video on that one day too. I've got everything. Not everything. Not everything like I have with my modern day component collection, but it's growing. The thing that sucks is we used to have council cleanup in this area, and every 6 months people would throw out all this rubbish. You'd be able to pick up old TVs, old radios, stuff with tubes in it. You know, you'd be able to get old parts. Now they stop the council cleanup, so you basically call up the council and arrange a pickup date for stuff to be taken. That's it. There's no council cleanup, so you can't just drive around and find old electronics to harvest old parts from anymore. So I'm left to whatever I rarely come across or occasionally buy online. But if I'm buying something online, it's like this. It's because I want to restore it and use it for myself. So I'm not going to really be harvesting much parts out of it other than the ones I change. And usually if I'm changing parts, they're dead. In this case, a lot of them aren't dead, but still, yeah. My point is I get a lot less parts coming in, old school parts these days, than what I did literally just 2 years ago. Let's just quickly, I know this isn't real accurate, but it's a 1 ohm resistor. My test lead's at 0.1 ohm. I can work out if a resistor's gone up. Now, if the lead's in the right jack, I can. Say 0.1 ohm. So really? Okay, cool. Wait, 0.3, that doesn't make sense. What? Hold on a second. What? Shit, have I already burnt these resistors out or something? Man, are these things that far out of tolerance? What's this? That there is a problem. I don't know if that's me from overloading it and I've burnt them, or if they're already like that. Or, no, because multimeter doesn't throw out test signals, does it, like a LCR meter? So the snubber's not going to be affecting it. Is there anything else in the circuit that could be affecting it? Is there any voltage offset on it? Let's see how it's 1 ohm. You think it would have shunted it all. No, it's not that. Is my range switch playing up? Bloody range switch again. Gets me every time. Right, well, that's good news. They don't look baked. Usually they start going black in the bottom first with the charcoal, not charcoal, it turns to charcoal. What do you call it? I'll just grab one and show you. I've got a bowl here. In the bottom of them they have this ceramic filler. I guess the whole thing's ceramic. It's like a harder ceramic casing with a almost as hard ceramic filling. Anyway. So, I'm going to take off all the capacitors I added, put the 10 nanofarads back, now knowing that I did stiffen the shit up out of the rails without even realising that they were the same rails that are actually important. Plus with all the other filtering I added in here, like lowering inductance, snubber networks and the shunts, you know, stabilised TL431s, even with MKTs on the back of them. Increase that cap value, increase that cap value, increase that cap value. It's well filtered. So I'm going to remove them, put it all back together and see what we get, and just start from scratch basically. Was there something else that I had to tell you guys? Because I left some notes for myself. Because I actually made a video yesterday and I watched it today, and it was like an hour, and I thought, man, I can explain everything I've discovered in this video and actually get stuff done and demonstrate some stuff for you guys in less than that time. So I just erased it until I'd start again. But yeah, that's what I'm going to do. I'm going to upload this video now so everyone knows what's happened. Yes, everything is oscillating. Basically it's powered upside down, so to speak, and that's where I went wrong trying to decouple things. I'm basically coupling things instead of decoupling them. And well, there is 100% not a single busted component on here. Everything's value is correct. So I guess I just removed the capacitors that I shouldn't have put on there, put the 10 nanos back, and I guess we should be back up to compensating op amps if I'm lucky. Let's hope I'm lucky. What I am going to do is I'm going to have a quick look at the LM301 data sheet. Actually, I'll just do it now quickly so I can tell you guys, because I've got an internal schematic on most data sheets of the transistor layout inside an op amp. The compensation pin is, where the VAS stage goes into the output as you'd think it is, because normally there's a capacitor in between that and the previous stage, but it's internal in the op amp. The LM301 doesn't have it inside, that's why there's the external compensation pin. And then the two balance pins that they usually tie it to the lower balance pin, the one that goes to the positive inverting side. Where's that negative inverting side? Hold on a minute. No, that's the positive inverting side. Oh. Doesn't even say on. Doesn't say anywhere. It's annoying. Looking at the schematic. Yeah, looking on the schematic even, it seems to be the positive balance pin and the compensation, which is basically coming off almost the output stage. So the reason I'm wondering about that is because I know these op amps are unstable and there was never any provisions for capacitors or RC networks on their input pins. So, you know, obviously I'll go do the op amps on the bottom board first because there's a chance that these are just feeding oscillation into the other op amps and that's what's causing them to oscillate. They might not need compensation still, but I've got a funny feeling they will. So who knows what it's going to be, whether it's going to be a mixture of snubbers between the output and the input, non-inverting input, or if it's going to be stuff between the inputs, but we'll work that out. We'll work out the values and we'll get it done. Basically what I'm going to do now is take off all these caps like I said, upload this video, and then start making a new video. Alright, I think I'll leave off here. I think I've covered everything I wanted to cover. I'm going to change that fuse to 1 amp before I continue. Thank you for watching, and I'll see you soon because I'm doing this now and it's 2:52 p.m. so I will be uploading another video this afternoon or tonight when I get this sorted. So stay tuned and thanks for watching. See ya.